Okay, so I'll start, and latecomers will have to see the recording. So welcome to my session about performance. I have a lot to share, so I will start quick. This is me, and I like to say I am a mad optimizer because I'm obsessed with performance and optimizations, and but I'm also kind of achiever of the impossible. So when you approach me with something saying, well, that's not possible, that's when I start to get interested. So like convincing Clarice to make the calculation engine much faster. So my first topic for today is AI in FileMaker from the performance perspective. We have a lot of new features in FileMaker for AI. How many of you have already implemented at least one? Nice. So I try to look at these features from the performance point of view, and for that I used my movie database, where I have all my movies, over 1,000 titles. And what I try to implement is semantic search, so that I could type like what I'm in a mood of watching right now, and so that it would recommend me like top movies to watch, so that I could easily select, because I guess you can imagine that just like being stuck thinking about, okay, what am I going to watch now, is a lot more difficult when you have so many movies. So first thing I tried was different ways how to store the embeddings and how it affects the search speed. So I basically used 4 different fields, 2 container fields in a same table and 2 container fields in a one-to-one relationship connected table. And in both tables, I had 1 field stored locally in FileMaker and 1 using external container storage. And as you can see on the chart, the main thing that I revealed was that it doesn't really matter so much whether it's over relationship or locally in the table, but it is really much slower when the container is stored externally. So specifically for embeddings, it's quite important to store the containers in the FileMaker, store the embeddings in the FileMaker, and not turn on the external storage, because the external storage will slow it down a lot. Although this may not be true in future versions of FileMaker, because the embeddings take a lot of space, and it's good to store them outside of FileMaker from the backup perspective. So I'm sure Clarice is looking into how to get to about the same speed with the external storage. But that's about how they implement it. So it's worth testing when a new version comes, whether it's still a big difference or not. The other thing is I was reading through the release notes for FileMaker 22, and in the release notes, Clarice mentioned that they modified, or they improved how they actually approach the semantic search with over relationship, and especially moving that to FileMaker server from the client in some cases. So I was testing with FileMaker Pro over wide area network over the internet, to connecting to the server with the same database with 1,000 movies, and I was trying to make it different, find the difference between the speed between FileMaker 21 and 22, but I didn't find any significant difference. So I don't know under what circumstances it will be different, but definitely not with a small database with 1,000 titles. And by the way, for the test, I made sure that I deleted the local cache before running the test. So it was not caused by everything being cached and so being searched in a FileMaker Pro. Well, this is what I used for the embedding. So you may know that FileMaker semantic search only uses a single field for the search. So you have to specify a single container field containing the embeddings, which means that for each record you have one embedding to evaluate. And specifically, when you have a structured data, like in my case, where for each movie I have a title, I have description, I have all the cast, director, some additional information. This had this cost. I had to kind of combine all that into a single field to generate an embedding for each movie. So this is how I did it. I was originally trying to make it structured like a JSON, but later on I discovered that today's large language models are much better with just plain text rather than JSON. So if you want to do like combined embeddings from multiple fields, it's better to just combine it into a single text, which reads nice for a human, because that's what the language models are trained for. I also was looking for the best models to use, and I discovered that what AI is really good at is giving you advice about AI. So I simply asked ChatGPT which language models I should try and compare. And I especially mentioned that I need them to be compatible with Czech language, because I had all the movie descriptions in Czech. So I didn't want to just use English-only model, because that would give me bad results. So ChatGPT recommended some models, and these are the models that I ended up trying. I tried OpenAI as a cloud-based model. Then I tried a tool that come pre-configured with FileMaker Server 22, where you can install the Claris AI server, and that has some models already pre-configured. And then I downloaded some models recommended by ChatGPT. And here is the performance table where I tried embedding and then semantic search. So I was searching in over 1,000 movies, and I created 5 different queries, like find me the best Christmas movie that children can watch, or find me an action movie with Nicolas Cage, and things like this. And I ran those 5 queries 3 times each over that database with over 1,000 movies, looking for the top 100 matches. And here you can see it in the chart. So as you can see, for the embeddings, OpenAI was relatively good in returning the embedding under 100 milliseconds. Under 100 seconds for all the 1,000 movies. The pre-configured models that come with Claris AI server were much faster. So you could think that, well, using the local server for embeddings is much better in terms of performance, but don't fall into a trap, because there are other parameters that you have to consider. And the other models, which were suitable for multilingual data, were about 2 or 3 times slower than OpenAI. I have to say it was running on a MacBook Pro with a M4 chip with 128 gig memory. So not the best, but definitely not bad configuration for offline models. Then I measured the searches, and you can imagine that you only do embeddings once, but the searches you run many times. So it's more important how fast the searches are than how the embeddings are fine. And in this case, all the offline models were kind of similar. but searching using the OpenAI was much slower. So specifically for the semantic search, if you are going to run the queries very often, it's definitely a good case for offline models, because you don't pay for the queries that you run over cloud-based service, but you also don't pay for the latency and the response time. But as I mentioned, there are other factors, and quality of the response is probably the most important one. There is no meaning in using AI if you get wrong results. So with using OpenAI, it wasn't so bad. I got pretty good results. With some of the built-in models that come pre-configured with from Claris, I guess that's mostly because of the language, because they were primarily targeted at English. It was quite bad. For instance, when I was asking for the Christmas movie that would be suitable for children, it recommended some really adult kind of comedy, even though it was Christmas related. And finally, the winner for me was a model that you can see just second from the bottom, which was Infloat Multilingual E5 Large Instruct, because that gave me a good balance between performance and accuracy. But again, a reminder, AI is good about recommending models, so that's the first step I recommend. Ask AI like ChatGPT or Claude to recommend like 10 models to try, and then run your test and compare the results, because there are thousands of models. If you try to look for the best model for your use manually, it's going to take ages. But don't trust only AI to select the one best model, because the real test on your data is the most important metric. Now, a little bit about the Claris AI server. I think what's absolutely perfect is that it opens this opportunity to complete beginners. You get a FileMaker server installer, you install it, you check one checkbox, and you get the AI server ready to use. You just install models, put in your Hugging Face access token, and that's it. Almost zero learning to get your language model running offline. Any other approach requires at least, I would say, an hour of learning, but in most cases a lot more. But it's also important to note it's not recommended to run the AI server on the same machine as the FileMaker server hosting your databases, because when you run the queries over the AI server, it can eat all of the resources on that computer, and then FileMaker server will not have enough to host your databases. On the other side, I tried exactly what's not recommended. I tried it on the same machine as the FileMaker server, because I wanted to know how far I can go and when it actually starts having problems. I created this small excerpt of that movie database. I only exported pictures, like the posters of the movies, the title and short description of the movie. And I was running 3 kinds of queries on the AI server to stress test it. So I had an iPad with this small database, and in a loop I was running creating an embedding for the image, creating an embedding for the movie description, and describing. This was embeddings was one type. Then I was running query to describe the movie, summarize the movie in a single sentence, to give me a summary of what the movie is about. That was second kind of query, and the third kind of query was the same, but from the poster. So I asked AI, by looking at the poster, just the image, Tell me what you think the movie is about. And in the worst case, when I was, I think, running the summarization of the pictures, the server was using 89 gigabytes of memory. And as you can see, the efficiency cores of my CPU were being used most, and the rest of the processor, the M4, was kind of bored. So even though for production it's definitely not a recommended setup, if you want to try the AI server from Claris, and you have at least a reasonable amount of RAM, like 64 gigs or more, it's definitely something that you don't have to be afraid of trying, because for testing with a single client, it's perfectly okay. And now what I was trying is that while stress testing that AI server from one client, on another client I was running my bench test database that runs the standard test, benchmarking how fast that FileMaker setup is. First I tried it with AI completely disabled. Then the second try, I enabled the AI server, but I didn't use it. It was just enabled. The third test was with the text embeddings. Then the next one with image embeddings. Next one was with summarizing the movies with one language model that was a small one, and then summarizing it with a bigger model with 27 billion parameters. And what you see here is kind of, that was my expectation. The more I stress test, the more I ask the AI server to do, the slower the FileMaker server will be. But this was the reality. So again, with a low load of the FileMaker server and enough memory, at least on a Mac, safe to test, because until you completely use all the RAM, it just runs fine, at least on the M4. So this was the exact setup that I was trying. And one thing that I discovered, specifically when generating embeddings, there was a difference between how each model was using my RAM. And this is a comparison just of 3 models that I tried of those recommended by ChatGPT. So the first one was pretty flat and no change. I actually ran the embeddings 3 times. So I just ran the generate embeddings for the whole movies database once, then regenerate them, and then regenerate them again. With the second model from Infloat, it was similar. It was just a little bit more because it's a bigger model. But when I was testing the third model, the BAAI one, this is what I got. So every time I ran the embeddings, it consumed a huge amount of memory, which it didn't return. And the memory remained to be used until I disabled the AI server. So even when I unloaded the model and loaded another one, the memory remained consumed. I had to completely disable the AI server and re-enable it to get the memory back. So that's one of the reasons why not to try it in production and only when testing, because when you try a model that has this problem, and I believe it's a model-specific problem, so probably not Claris's fault, but there seems to be something that's not handled in the Miniforge AI server that's used by Claris for this feature. You can get a model that has a memory leak like this, and just by using it for embeddings, you can very quickly kill your server. And this was just for 1,000 movies. So after running it 3 times, it generated just 3,000 embeddings. The semantic search is in practical world used for generating embeddings for 1,000,000 records. Because if you have just 1,000 records, it's easy to search without without AI. So some best practices that you can learn. Claris has a very good detailed white paper about best practices for using AI. And there are some people who dedicate a lot of time to AI testing and AI research. These are names of the most known people in the Claris community. So don't hesitate to try to reach out to these people if you have a real practical need for AI. They can help. They are willing to help. You can hire them to help you. They have so much experience that we can hardly catch up with them. And now a little bit of fun, just so you can see how important it is to choose the right model to do the job that you want to do. These are 3 examples of movie posters which I got the AI model describe based on the picture. And these are the 3 descriptions that I got. So one was a determined woman stands in a futuristic city escape, suggesting a science fiction, action, or thrill movie. The second one was a group of people are running through a forest, suggesting an action or thrill movie. And third one, a young woman with fiery red hair stands defiant against a backdrop of thrilling chaos, suggesting a story of rebellion and strength in a fantastical world. So guess which description was created for which of the movies? And it's this. So definitely not the right model to use for this task, right? And what was funny, for some reason, the model was seeing a woman in 90% of all the images, even though there were almost no women. So, important takeaway, AI is asking for a new way of thinking, especially about performance, because we are no longer just standing against, well, is this faster or is that faster? We have to take multiple different factors into account, such as the quality of the results, and the other thing is privacy, for instance. But also, even the performance metrics are not simple, because it's not only about response time, it's about amount of data being processed, amount of RAM being used, measuring the embedding time versus the semantic search time, for instance. So it's a lot more difficult to compare different approaches from the performance perspective. And in the end, you have to find the right balance between accuracy, performance, and privacy. And basically, if you want to get all of 3, the more you get from all, the more you have to pay. So another dimension is the cost. So if you give up 2 for 1, you can get it very cheap, but then you lose those 2 parameters. One approach that can help a lot, especially for running on a local models, if you don't really need the response immediately, you can just create some kind of dispatch queue where you send your request and wait for the results, and you get the notification when the results is ready. So this is a database that we created for our own purpose, where we simply queue our AI requests, and it tells us when they are ready. And the next thing is you can actually combine the probabilistic AI functionalities with a deterministic functionality of the FileMaker database. And by doing so, you can get a lot higher accuracy without compromising the performance too much. So for instance, I mentioned that I had to combine all the different fields into a single text field to generate one embedding. I could get much more accurate results by having an embedding for each field separately, then running the semantic search multiple times for each field, which would give me the score for the top movies. And then I could calculate, because now FileMaker 22 has a new function to combine cosine similarity of two values. So I could calculate the overall score combining all those factors. I could even give each field a different weight. And based on the calculated score, I could select the top matches. It would mean running maybe 5 or 6 semantic searches instead of one, but you could see that the semantic search itself takes just a few milliseconds or maybe a few seconds in a large database. But by combining the scores, I could get much more accurate results. By the way, that would also allow me to use a smaller and faster model. So I could achieve the higher accuracy not only by using bigger models, but by using this combination of the different approaches. And I could also use for some fields like age of the movie when it was shot. Instead of using semantic search, I could use find by natural language and let the AI just find those accurate values using the normal FileMaker search. So that was about AI. Now I have a quick story about optimization. As you may know, we also provide performance optimizations as a service. We quite often help our customers optimize their solutions. And one example was Parker Hannifin Corporation, where we help them on a regular basis. And they had a database that they called PACS. That's a Part Add Change System. And it's a database that manages their processes when a part gets reclaimed. They have to fix it. Each part for a filter has components. Some of the components have other components. So to fix that part, they have to trigger several different processes. And one process is waiting for another process and so on. In this database, they had a big problem with waiting time. So for instance, just to display a list of tasks that they are supposed to work on that day was taking quite a long time. I think that was task filter, so it was taking 3 minutes to display. This was 3 seconds. No, yeah, 3 minutes. So it was quite painful, just switching to the layout and waiting for it to load. And so we implemented FMBench to measure all the scripts that they were running, and we sorted them by the time it took for each script to run, and then also by first on total time and then on average time, how long it took. So the first round of discovery was that we got only 28 client sessions, collected data from 3 users. So and that was because so many of the users were not running the latest version of FileMaker, and we used some function that was relying on the latest version. The other thing was that the scripts, when I mentioned 3 minutes, it was actually 3 seconds, and the 3 seconds were actually something that was not experienced. The script was very fast, but the users were still waiting a very long time for the layout to appear. And based on that, we discovered that after the script runs, the layout is taking a long time to render before they can start using it. So we had to measure layout rendering. And this is something that I discovered a few years ago, that the most accurate way to measure layout rendering is when you go to the layout in a script as the last script step, and then install onTimer script trigger to run another script, because that another script will not run until the layout is completely rendered. So you go to the layout, collect a timestamp, install onTimer script trigger, and in that script trigger you collect another timestamp, and you have the exact time how long it took to render the layout. So when we combine those two values, these times were on the script and layout combined together. As you can see here in the production on Windows, half a second to run the script and 10 seconds to render the layout. So we started examining the layout, and we discovered that the main reason for it was in the top. It was showing the number of tasks in each status by calculating them with unstored calculations based on a two-way relationship. So we looked at it, and the way it was getting slow, there was a unstored calculation getting ID of the record, and based on the status of the record, whether it's relevant or not relevant, it was giving us the ID, a copy of the ID to the calculated field or an empty field. So in the top level, they were calculating the number of IDs in the related records. And the way we optimized it is we got rid of those two hook relationships, and instead of moved the one unstored calculation to the top level, and instead of combining all the related records and having them calculate whether that record is relevant for us, we just calculated the list in the top level and only counting the related tables. So basically it was based on the roles. So for instance, the user was assigned a role like engineer, and the original approach was that for every task there was a calculation: am I an engineer? Then copy the ID. I'm not the engineer, let's make this value empty. Our approach was that on the other side we listed all the IDs of the status that was relevant for engineers. So on the top level we just listed all the roles and connected the records by the role. And in the end, the rendering after optimization, we got it down to 605 milliseconds on the production. As you can see, the script actually is not running faster, but that's not a problem because the script was not the bottleneck. So the other thing is we could make it even faster, for instance, by not using unstored calculations at all, but the point was that the target was make it fast enough for the customer. We could spend like 10 times more time to make it maybe under 100 milliseconds, but that would be a wasted time. So another thing that is important when optimizing performance is don't look for perfection, look for sufficient results. So my takeaways from this are we always consider perceived performance. If we measure something, that does not necessarily need to be the actual experience of the users. So when you benchmark your solutions, always compare the results with what the users are saying, because you may be missing something. In our case, it was the layout rendering time. Another thing is FileMaker Pro is still mostly single-threaded. So downsides of it, disadvantage of that is that even if you have a faster computer, it will not help because it still goes through a single thread to render the layout. But the benefit is that you can benchmark the layout rendering. And no need to over-optimize. If it's sufficient result, go forward with another task, and you can re-optimize when it becomes too slow again. Now, what I would like to mention as well is that we have a new version of FMBench. So as I mentioned, you can use FMBench, which is our tool for benchmarking and for finding bottlenecks. The new version of FMBench has a neat new feature. So if you are using other analytical tools, such as Inspector Pro or Base Elements, we now have the possibility that in one tool you click a button to reveal more information about the same script, for instance, in the other tool. So if you find a bottleneck with FMBench and you want to learn something about that script, in Inspector Pro, you can click a button, Inspector Pro shows you that script. If you have a script in Inspector Pro and you want to see how it performs in a real installation, you can click a button in Inspector Pro and reveal that script in FMBench. So that was the optimization story. Now, real comparison between FileMaker 2024 and 2025 in terms of what became faster, what became slower, and so on. For this, I tested a combination of my computer as a client and a relatively older PC running Linux Ubuntu with a FileMaker server. And I was using the bench test database, which is available on our website for free, to run the standard test, which consists of 111 cases tested. And just a note, in this case, I'm comparing score, which means that the wider bar means faster result. So here you can see that the overall performance is similar between the two. But in this case, I was measuring time, and specifically sorting 10,000 records by unindexed unique text field. I discovered was much faster, like twice as fast in FileMaker 22. So when I was running all the tests, the combined score was similar, but there was this particular one test which surprisingly gave me much better results in 22, even though it was not announced. There was nothing in the release notes saying that sorting has become faster, but I did find it faster. One more surprise was this slow graph test. Sorry. Just get rid of this. So as part of the bench test, I have a database submitted by Vincent Lunier some years ago, which he inherited from one developer. And it had this huge relationship graph. And one issue that he had was creating a record in this database in a completely isolated table, not involved in any relationship, was taking like 1 second or something like that. One created record. The other thing is that also opening this database is taking a long time. And again, something that was not announced that there would be any expectation of change. When I was closing this database, it was taking significantly less time than in FileMaker 2021. So there are things that Claris is improving without telling us, and maybe without even knowing, but it's a good sign. And then that leads me to another thing, and that's what was announced. FileMaker 22 has a significantly improved functions for working with JSON. And one of the features, or one of the techniques that JSON is used heavily in is virtual list. How many of you have heard about virtual lists? Okay, so just briefly, it's an invention from Bruce Robertson. It's a way to minimize the amount of requests going between FileMaker client and server. Basically, you run a script on a server requesting it for data, asking it for data. It returns the data in some form as a result, and then you store the data in a local global variable and display it either in a portal or in a list view using unstored calculations directly from the global variable. By having all the data in a global variable, FileMaker Pro does not have to query FileMaker server over and over again because it's all local, so it's much faster to work with the data. The point is that in the past, when I tested different approaches, it was much faster to have the data stored as a tab delimited text in a global variable because it was much slower to extract data from a JSON structure. But with FileMaker 22, it's started becoming much faster to deal with the JSON, or sometimes at least equally fast as the tab delimited text. So from now on, JSON is a good structure to keep in variables and access because it's much faster to work with it. And the reason is that FileMaker now keeps, as long as you keep the JSON in memory, FileMaker first parses the JSON into a binary object and then keeps the binary object as long as it stays in the memory. So instead of having to parse it over and over again, it just uses a native JSON functions inside. So this is the test I tried in the virtual list, and that gave me that nice result. As part of our bench test, we recently added a new tab called Initiative 24, which is focused on calculation performance. In there, I added some specific tests to test looping through JSON and creating JSON arrays and extracting values from JSON, where initially, when the FileMaker 22 was released, I discovered that creating that array was about twice as fast, and looping through the array and extracting values from it was about 12 times faster. So that's what I shared immediately after FileMaker 22 was released. This was the test that I was running there, and it already looked very nice. But what I discovered later when I watched the FileMaker session is that it was actually a factor of the size of the JSON. And the bigger the JSON was to loop through, the better the result was. So with trying with 5,000 nodes in the JSON, the actual values were measured were even better. And here's the result for the 5,000. So looping through two-dimensional JSON with 5,000 nodes on M4 Mac is 28 times faster in FileMaker 22 than it's in FileMaker 21. So that's a really good news. Under the hood, FileMaker presented a session at Claris Engage, also at the Vienna Calling Conference in Vienna. I definitely suggest watching his session to understand what's happening behind the scenes, and leverage that JSON functionally because that's going to give you significantly better performance. Now, when Clay talked about that there is this new functionality, there is also a new function called JSON parse. And that function explicitly pre-parses the JSON and keeps it in memory. So in response to that, I suggested a custom function that you could use so that you leverage the JSON parse function in FileMaker 22, but still retain compatibility with FileMaker 21. But later on I discovered that's not needed at all, because you don't have to use the JSON parse function. Every JSON function that returns JSON as a result returns it as a parsed JSON with the binary object in memory. So as long as you use the JSON functions in FileMaker to create the JSON, you don't have to worry about parsing it because it's already parsed. And as long as you keep it in memory, like in a local or global variable, you automatically get that speed improvements. So all these functions return preparsed JSON as a result. And one more great feature, which doesn't give you better performance immediately, but you can leverage it in a great way, is getting record IDs from found set and going to a list of records based on that. So you can get the list of records from the current found set in these 5 different forms. What's quite interesting is that you can also get like intervals. So if your current found set is like 10,000 records, but many of them are in like consecutive numbers, you don't have to get every single ID. So the list can be relatively short. And then you can use the script step go to list of records, and it immediately restores that found set. What's quite important to know about this script step does not use a single call to the server. Not a single one, because all it needs to reconstruct that found set, it already has. It only needs the record IDs. So it doesn't have to call FileMaker server. If you do a go to related records, even though it can be very fast, it's still invoking at least one call to the server. Go to list of records does not. So especially when you have a slow connection with a long latency, this can give you a lot of extra speed as well. So for this purpose, in the bench tests, I also added a few tests for specifically targeting go to list of records. And these were the results that I got comparing it to the fastest methods that we had until now. So without the new features, getting a list of records over relationships, the fastest way to use was having an unstored calculation in the target table that will give you record ID. And getting a list of those record IDs. That was the fastest until FileMaker 21. Now, when you get the list of records from the found set, again, even getting the list of records doesn't need any FileMaker call because it already has the found set locally. And this is the difference in timing. And you can say, well, 150 milliseconds is not a huge time. But if you have it in a logic of some script that does this in a loop 1,000 times, 1,000 times 150 milliseconds is 150 seconds, right? So isn't it better to have just 1 second to do all that? And this is restoring the found set. Again, because it doesn't have to call the server, it's almost instant. And actually, the values that I measured here are comparable to doing nothing. So I also tried to evaluate like 2 timestamps without doing any other action, and it was similar. So So the time to restore a found set is almost the same as a script step that doesn't do anything. And that leads me to my favorite topic, and that's calculation performance. And some people, you know that I'm trying to ask everyone to vote for faster calculation engine, and we are getting close to making it the #1 idea in Claris community. But let me tell you why I think it's important. And that's because people today are busy. They don't have time. So performance is getting more important than ever before. In the past, people were used to wait few seconds for a computer to respond. Today, when you are waiting 2 seconds, you are getting nervous that the computer is not returning the results. iBlink takes about between 200 and 400 milliseconds. And that's a target time for any response time on a computer if you want the users to feel happy. So if the user clicks a button and doesn't get the results in 400 milliseconds, they are going to consider it slow. And another proof that people are busy. I wrote an appeal early this week, I think it was last week. I wrote this appeal in the Slack for this conference for people to vote for the faster calculation engine. And I gave them exact instructions. Just give me these emoticons to indicate how many votes you have collected. It was just one paragraph. And it was targeted in a Slack channel with almost 200 people. So out of 200 people, 15 people responded, and only 2 read and followed the instructions. So, and this is a pattern. It's not specific to EngageU, it's not specific to me or my request. I see it everywhere. People are not reading, people are not spending time because they don't have enough time. They get over busy. When you send someone an email with 3 paragraphs, they are not going to read the second one. It's only rare when people read the second paragraph. They read the first one, last one, and respond. So that's today's reality. And the other reason is calculations can be added everywhere in FileMaker. I built this layout as an example, and I will make the example hopefully available for you to download today. Very simple layout, and the purpose of this for this was find out in what order things are evaluated when a layout is rendered, so that just like I mentioned, you can measure layout rendering. It's also good to know in what order things are evaluated on the layout and what may be causing the delays. And all the structure is that there is a group of things on the left side and group of similar group of things on the right side, so that I also find out how the order of rendering is affected by the physical position on the layout and how it's affected by the layers on the layout. So there are just 2 fields, 2 layout calculations, 2 button bars, 2 tab controls, 2 portals, and 2 web viewers. And guess how many times, in this case, FileMaker triggers the calculation engine just to render this layout? Who thinks it's more than 100 times? Who thinks it's more than 500 times? It's actually 600 times and 92, since 692 times. And the even worse thing is there are many calculations that are evaluated unnecessarily often. This database has 40 records. The layout is based on the first record, and the portals are showing records from 2 to 40. So the first record is only shown on the layout itself, not in the portals. Yet, the privilege to view that first record is evaluated 66 times. I'm asking why. So in addition to making the calculation engine faster, what Claris can also do is use call the calculation engine less often if it doesn't need it. The whole layout rendering took about 87 milliseconds. So within 87 milliseconds, how likely it is that the privilege to view the record changes? And if it does change, how many of you would worry about waiting 87 milliseconds for that change to actually be applied? We don't need to evaluate the privilege more than once per this period, right? So FileMaker could cache that value for 100 milliseconds and then evaluate it again, and we would evaluate it 66 times less. The other thing that this revealed was the only actions that happened after starting that on-timer trigger was rendering the web viewer. So everything else, including the portals, was evaluated before my on-timer script trigger started, which means that it is really still possible to calculate or benchmark the total time used for layout rendering with that on-timer trigger that I told you about before in the optimization story. Which leads me to my initiative. This is a picture from this morning. We are still looking for 114 people to vote for faster calculation engine. If you have not voted yet, please do so, because everyone, including you, is going to benefit when Claris finally makes the calculations faster. And if you have voted, ask someone who has not, because that's going to help as well. So that's it from me, and I'm ready for questions. Anyone? No questions?
Thanks for a nice presentation. I was wondering about CPU performance when using the semantic search.
Mm-hmm.
Does it jack into the FileMaker server process, or is it separate?
Okay, so it's a completely the AI server is a separate process.
Yeah.
And based on some things that I found, the AI server is actually trying to use the performance cores, while most of the FileMaker server activities are sufficiently handled by the efficiency cores. And by the way, if you use the right model, which is optimized to leverage the FileMaker, the Apple AI features, the ML. I don't recall the exact library name, but yeah. So if the model leverages the neural engine in the core, then it's using completely different part of the CPU, and the only shared component is the memory. And the benefit of Apple Silicon is that the memory is on the chip, and all the cores are on the same chip. So the transfers of data between the processor cores and the memory are extremely fast.
Thanks.
You talked about quality of semantic search.
Mm-hmm.
How is quality determined? How do you determine is the answer good or not?
Okay, so in my test, I simply formulate a request what kind of movie I would like to watch, and in the top results, I was checking whether my request was fulfilled or not. So I had like I combined three requests, like let it be about Christmas, it needs to be a comedy, and it needs to be suitable for children. So when the movie matched all three requests, then it was the right match and scored the best. If one of those criteria did not match, then I consider it worse, and so on. No more questions? Okay, then thanks for your attention, and I hope next year we will be able to talk about FileMaker 26 being significantly faster with a lot more calculation functions than just JSON. Thank you.